Hi everyone. Today is 4.3, slope-intercept form. We're still talking about graphs of lines or linear functions, and this is going to be our next and probably best shortcut for graphing lines. So first of all, this right here is what we call slope-intercept form. Y equals mx plus b. Now that is a linear function, because remember, a linear function just means x to the first power by itself, and that's what we have. So what we're saying is this generic form right here, you have y equals, there's some number in front of x, it might be 2x or 10x or negative 1/2 x, there's some number in front of x, and there's also some number being added on the end. Plus 5, could be negative, minus 7, plus or minus some number on the end. Okay, if the equation is in that exact form, y equals mx plus b, it's what we call slope-intercept form. Now, the reason we call it slope-intercept form, those two numbers that I put the arrows on, m and b, the first one, m, gives you the slope of the equation, or the slope of the line. The second one, b, gives you the y-intercept of the line. So it's slope-intercept form. It gives you the slope, and it gives you the y-intercept. So let's start off with an example, just to make sure we understand exactly how this works. I'm kind of working backwards here. And we're going to write an equation in slope-intercept form for a line with slope of 6 and a y-intercept at 0, negative 7. So first of all, let's start with slope-intercept form. Slope-intercept form was y equals mx plus b. It's a very important equation you're going to want to remember. And all we have to do is put the numbers in the right place. So I told you in the question the slope was 6. And I told you on the last slide, the slope is m, it goes right there. Now I told you the y-intercept in the question is 0, negative 7, so I'm going to focus on the negative 7. The 0 is just, that's what makes it the y-intercept. And that number is what goes in for b. So the answer to this question, as long as you know what you're being asked and you know how to use slope-intercept form, there's no work to it. It's just putting the answers in the right place. So the answer is y equals 6x, and you could say plus negative 7. It wouldn't be wrong, but usually if it's a negative number, I just do minus instead of plus. So the answer is y equals 6x minus 7. So if you know the slope and the y-intercept of a line, it's real easy to make the equation. It's just y equals slope times x plus y-intercept. Y equals mx plus b. Now, the more important thing about this equation, though, is that it makes it really easy to graph a line. If I give you an equation that's in slope-intercept form, y equals mx plus b, all you have to do is, number one, plot the y-intercept. That's the one point that's automatically given to you in this equation. If you know what the y-intercept is, you just from the center go up or down that many spots. If it's a positive number, you go up that many, mark a point. If it's negative, down that many, mark a point. Now from there, we're going to use rise over run from section 2, from yesterday. We're going to use rise over run from that point to find one other point. And then remember, 2 days ago, 4.1, we said it only takes 2 points to draw a line. If I have the y-intercept, I do rise over run, plot another point, that's my 2 points. I'm just going to draw a line going right through them. So it's actually real simple. Let's go ahead and try it out. All right, so we're going to graph the line y equals 2x minus 4. Now, before I do anything else, just by looking at the equation, I notice it's in slope-intercept form, which tells me that the slope is positive 2, and the y-intercept is negative 4. So let's start with the y-intercept. Remember, that's easy, that's a point. You can always just plot that one. If it was plus some number from the middle, I would go up that many. Since this is minus 4, I'm going to start at the middle and count down 1, 2, 3, 4 spots and put a point right there. There's my y-intercept. All right, now, to find a second point, all I need is a slope. Now the slope in this equation is 2. Now here's the thing. In order to do rise over run, you need to have a fraction. So if the slope is a whole number, the rule for turning a whole number into a fraction, just put it over 1. If I have the number 2 and I want it as a fraction, it's 2 over 1. Because remember, fractions mean divide, and 2 divided by 1 equals 2. So 2 over 1 is the same as 2. That's just the fraction version of a whole number. Which means rise over run. From my y-intercept, I'm going to rise, go up 2, and then run 1 to the right. So let's do that. In fact, I'll even mark it in. I'll show you in red here to show what I'm doing. From the y-intercept, rise 2, run 1. The second point is going to be right there. Now it only takes 2 points to draw a line. So at this point, I'm ready to answer the question. I can draw the line that goes right through those 2 points, just like that. Now if I wanted to, I could keep doing rise over run. Up 2 over 1, there's a new point. Up 2 over 1, there's a new point. But I don't need to. You really only need 2 points to make a line. All right, let's try another one. This time, the slope is -3 over 5, and the y-intercept is 2, positive 2. So let's do the same thing as last time. Let's start with the y-intercept. Positive this time means up, so from the center, count up 2 and mark a point. That's the easy part. You're always looking right here. If that's a positive number, count up that many and mark a point. If it's negative, count down that many and mark a point. Now this time the slope's already a fraction. But it's negative. So you might think to yourself, okay, well, where do I put the negative? It actually doesn't matter. You can do, for rise over run, you can do -3 over positive 5, or positive 3 over negative 5. And I'll do both, just to show you. Let's do this one first. If I do -3 for rise, that means down 3 here. Positive 5 for run would mean right 5. 1, 2, 3, 4, 5. It would put me right there. So that's -3 over positive 5 for rise over run. Now let me show you what the other one would look like. Let's say I did this one instead. So go back to your original point here. This time rise is +3, up 3, and run is -5, which would be 1, 2, 3, 4, 5 this way. And it would put the point right there. Now see, all 3 of those points are on the same line. So it doesn't matter if I did the green one or the red one. Either way, the line is going to go right through just like that. So if the slope is negative, it doesn't matter if you just make one of each. It has to be one positive and one negative. You can do positive rise and negative run, or you can do negative rise and positive run. Either way, it's going to get you the right answer. It just depends on whether you did the green one, where you count up and then back, or the red one, where you're counting down and then forwards. All right. Let me do one last example with you guys. And this one's interesting. We have 2x minus 3y equals 12. It's not slope-intercept form. And I'm going to show you 2 ways to graph this. Number 1, let's put it into slope-intercept form first. We did way back in Module 1, we did a section on formulas where I said, let's just take this equation and solve it for y. If I want to solve for y, the first thing I want to do is move that x, so I'm going to subtract 2x from both sides to cancel it out. So now the -3y is by itself. I can't add those together. One of them's a number, the 12, and one of them has an x. So let's leave the -2x. I like having x in front. And since that's a +12, I'll put +12 on the end. Now to finish solving for y, we need to cancel out the -3. So I'm going to divide both sides. And dividing both sides, another way of thinking about that is divide each piece separately by -3. So -3 cancels with -3. And y equals -2 over -3. Negative over negative is positive. So I'm going to make that a positive 2/3 x. And then for my constant part, for my number part, we have a positive 12 divided by -3. That would be -4. Positive divided by negative is negative, and 12 divided by 3 is 4. So now I did this little bit of extra work over here. Now it's slope-intercept form, and I can graph it just like our others. So let's do that. My first point, the y-intercept is -4, so I'm going to count down 1, 2, 3, 4. Now remember, I didn't know that by looking here. There's no y-intercept up there. It took that work I did in the little circle in the top right to know that. Now the slope is positive 2/3. They're both positive, so I'm going to rise 2, run 3, up and to the right since they're both positive. And I'm going to put another point there. And again, just to show you, if I want to do rise over run, you can do it as many times as you want. Up 2, over 3, put another point there. But either way, this is the line we're looking for. Okay, so I took a little time to do the extra work at the beginning to take that equation and put it into slope-intercept form so I could use my slope-intercept form trick. But if you remember from 2 sections ago, we learned a different trick for this. The intercept trick, or I called it the cover-up trick. So let's do it that way and show you get the same answer. I said, let's find the intercept. So the first thing, let's say y is 0. If y is 0, the whole y part disappears, and I get 2x equals 12. Remember, we're saying if y equals 0, -3 times y also equals 0, and that whole part just disappears from the equation. So 2x equals 12, divide by 2, and your x-intercept, 12 divided by 2 is 6. Well, that's actually this point right here. Now go back to the beginning, and let's say this time x is 0, so this part disappears. And you have -3y equals 12, and you solve for y by dividing by -3. And 12 divided by -3 is -4. That's this point right here. So you would have gotten the same line. You would have found the intercepts. You would have drawn the line going through them without ever knowing the slope. You could have drawn that light blue line either way. So we've learned 2 shortcuts here. Shortcut number 1 is for, well, shortcut, I won't call it number 1. Shortcut today was for slope-intercept form. If it's in slope-intercept form, we got a great shortcut for it. You plot the y-intercept, you use rise over run, you draw your line. Super quick and easy. But when the equation isn't in slope-intercept form, let's say the equation is like this example here. Oops. There it is. Okay. So our equation is like this one here. Then you have 2 choices. You can use the intercept trick or the cover-up trick that we learned in 4.1, or you can do that extra work in the top corner there. You can put it into slope-intercept form and use that shortcut.